Chemical kinetics is the science of the speed of reactions. It governs everything from complex chemical reactions um, to lengths of times in cooking recipes. It deals with many things, but primarily it concerns the temperatures of the reactions and concentrations and the presence of catalysts. These three things it dictates are what determines the speed of reaction. As you increase the temperature and concentration, or the amount of catalysts, according to the science, the reaction speed is supposed to go up. This effects can be seen best without complicated laboratory experiments in the two categories of reactions: the clock reactions and the oscillating reactions. The clock reactions, which by definition are reactions that pause a little bit before they actually occur, are the first of these two groups. They work for, by using two sub-reactions which inhibit each other's movement and for certain lengths of time until the changes take place. There's several examples of these: the formaldehyde clock reaction, the thiosulfate clock reaction, the vitamin C clock reaction, and many others. So the last two in particular are what you commonly see. They both are basically the same reaction. The vitamin C one just substitutes vitamin C for thiosulfate, as vitamin C is a much more economical and common substance. The oscillating reactions, on the other hand, are a bit different. They, unlike the clock reactions, change a little bit differently. Instead of just going one way, they go back and forth. They accomplish this in many different ways depending on the reactions, and they're much too complicated to discuss in detail here. But basically what happens is this: there's a single overarching reaction that feeds several smaller reactions as it progresses along. These sub-reactions switch based on concentrations of various chemicals and such, and they feed each other as they keep going back and forth as the reaction progresses, and as the main chemical amount decreases until it's done. The prime example of this that you see nowadays is the Briggs-Rauscher reaction, although it is a fairly new invention. It's a combination of two earlier ones. These two ones make good demonstrations basically because they exaggerate the effect. I use these for my investigation for that very reason. I devised two problems to test in my investigation. The first one involved the vitamin C clock reaction. Is this: which of the following speeds up the vitamin C clock reaction most effectively at ordinary levels, i.e. what, not going to 1,000 degrees or anything? An increase in temperature, an increase in the amount of hydrogen peroxide, which is a catalyst in this instance, or an increase in the amount of iodine, which is a key reactant of the vitamin C clock reaction. The second problem, which is the one that dealt with the Briggs-Rauscher oscillating reaction, is this: what are the effects of varying temperatures and varying amounts of hydrogen peroxide, which in this case is the key sustaining reactant, on the Briggs-Rauscher oscillating reaction, speed of oscillation? Note that I'm not testing the length of the Briggs-Rauscher oscillating reaction, just how fast the sub-reactions go in a certain period of time. My hypotheses for these experiments were these. For the vitamin C one, I hypothesized that adding iodine would be the most effective of the three options, followed by adding hydrogen peroxide, and that followed by adding temperature. The reason I hypothesized that is this: the temperature difference is not as great of a ratio as say the amount of hydrogen peroxide difference and the iodine difference when we deal with it in terms of Kelvin. And for the reason I didn't put the hydrogen peroxide first is I hypothesized that would dilute the actual reactants and thereby counteract it itself. For the second problem, which is the one with the Briggs-Rasher reaction, I hypothesized that heating the reaction would speed up the oscillations, but that adding hydrogen peroxide would not significantly speed up the oscillations. For it is primarily the sustaining reaction. It doesn't have much to do with the how fast it goes. To test these, I designed several procedures. For the vitamin C experiment, I designed a base experiment and varied off of it. Here's a base experiment, and then I'll tell my variations afterward. I made a vitamin C stock, which was 9 500 milligram vitamin C tablets in 270 milliliters of water. This I used for more than one repetition because it would be way too much. Then I took 2 cups and labeled them A and B, and then I poured 60 milliliters of water into each. To A, upon doing this, I added 10 milliliters of vitamin C stock, and to B, I added 15 milliliters of hydrogen peroxide and 2 milliliters of starch. Having done this, I added 5 milliliters of iodine to A. This turned clear as I stirred it for 10 seconds. I just poured the 2 mixtures together and stirred it for another 10 seconds. Meanwhile, I started a stopwatch and let go until the reaction changes color, as that is how this particular one works. And then recorded the data. And then, after I was done with that, I did the other groups, which were the 0, 50, and 100 degrees Celsius groups, the 0, 30, 45 milliliter of hydrogen peroxide groups, and 0, 10, and 15 milliliters of iodine groups. And the reason I chose those ones was because 30, 45 was 2 times and 3 times respectively the original amount, and 10, 15 milliliters of iodine is 2 times and 3 times the original amount. It makes a smooth graph. For the second experiment, I also likewise designed a debate this experiment with the help of guidelines. First of all, I labeled 2 cups A and B as I did last time. To A, I added 10 milliliters of water, 1/2 a scoop of sodium iodate, which a scoop is approximately equal to 0.2 milliliters, but I did not calculate it all out. Then a scoop of sulfonic acid. To B, I had 10 milliliters of hydrogen peroxide, 1/2 scoops of malonic acid, and less than 1/2 of a scoop of manganese sulfate. I usually averaged it out 1/4 of a scoop. It would be, I think. And then I added 3 drops of starch solution, which these were larger drops, just for the record. I poured B into A and started stopwatch the last time, and swished it twice every 30 seconds for 3 minutes. And meanwhile, I counted dark blue oscillations that occurred in that time period, and then recorded that as my data and averaged it up. My other groups, likewise with the 0, 50, 100 degrees Celsius groups, then the 0, 20, 30 milliliter hydrogen peroxide groups, a lot like before, I chose them based on their ratios. The vitamin C clock reactions variable was the amount of hydrogen peroxide, iodine, and heat. I tested them separately so that it wouldn't mess each other up. The constants were the levels and types of other ingredients, the equipment, and the time stirring, the number of repetitions they did each. My control groups were the base group, and the groups that had 0 hydrogen peroxide and 0 iodine, and technically 0 degrees Celsius, although because of Kelvin that doesn't count as much. I did 3 repetitions for each category in the subgroups. For the Briggs-Rauscher reaction, my variable was the heat in the hydrogen peroxide, the constants of the equipment, other ingredients, time, number of stirs, and basically the same thing as last time. Control groups or base groups and the zero groups. And there was 3 repetitions for each group, though it totals up much less because I didn't have as much I was testing. My results were as follows. For the vitamin C reaction, the average for the base base experiment was 546 seconds. I'll mention this again in the hydrogen peroxide and the iodine averages because it makes them make a lot more sense. Then for the averages for the temperatures, it was for the 0 degrees Celsius, it was 742 seconds, 50 degrees, 55 seconds, and 100 degrees, 118 seconds. It did show a downward trend. For the hydrogen peroxide averages, for the 0 milliliter trials, it didn't work at all within 20 minutes, which was the max time we set for it. For the 15 milliliter ones, which is the base experiment, was 546 seconds, like I said earlier. For the 30 milliliters, it was 234 seconds, 25 milliliters, 175 seconds. Again, it showed a downward trend, though perhaps not as pronounced as the temperature one averages. For the iodine averages, I got the following. Like with the hydrogen peroxide, the 0 milliliter group did not work within 20 minutes. For the 5 milliliter group, which is the base group, I got 46 seconds. The 10 milliliter group, I got 80 seconds. And for the 15 milliliter group, I got approximately 0 seconds. This one, the iodine overpowered the vitamin C and the vitamin C did not clarify it, and the results are kind of questionable on that one. All of them did show a downward trend in that group. The Briggs-Rauscher reaction in blue cycles per 3 minutes, and my results were as follows. For the base average was 15.0 blue cycles per 3 minutes. My temperature, the averages in the temperature groups were for the 0 degrees Celsius, it was 13.0. 50 degrees Celsius, 15.3. 100 degrees Celsius, it was 14.0. These were interesting. First they went up and they went down. As it went towards the higher temperatures, it had a tendency to cut off earlier. Also, the data jumped around a little bit more. For the hydrogen peroxide averages, for the 0 milliliters, I particularly got 0 cycles, as it did not work. The 10 milliliters, I got 15.0 cycles. 10 milliliters, 16.0 cycles. 10 milliliters, 16.3 cycles. It went up, but not very significantly. My conclusion for the first experiment is as follows. The iodine did have the most speed, which supports my hypothesis, although as it got higher and higher, it glitched up the experiment more and more. The second most speed was the temperature. That did not support my hypothesis. I had hypothesized that hydrogen peroxide would be the second most effective. Third most effective one was the hydrogen peroxide. Interestingly, though, it was the most controllable one. The temperature, I had issues with keeping the temperatures up, and the iodine messed with the results of the experiment, as I mentioned. The second experiment, the one with the Briggs-Rauscher reaction, I got the following results. The temperature, both the temperature groups and the H2O2 groups were somewhat inconclusive. The temperature one went up and then down as it increased, which does not support my hypothesis, but it's such a slight change that it's hard to say. And like I said before, some of the later ones started not working, so we have to test it again. For the hydrogen peroxide, it went up, but not significantly, which doesn't support my hypothesis, but it's hard to say with under the current circumstances. For both, there are lots of improvements to be made. Better methods of taking the temperature of the water and keeping it up. would be desirable if someone is to repeat it. Better methods of stirring, other than what we did, would be better because the stirring methods that we used were not very controllable. The first one I had to use a spoon. The second one we swished it, and the amount of effectiveness on the other one is hard to measure. There's applications of these, though it's not as direct as some other science projects, perhaps. It shows how amounts, reactants, or temperatures can wreak havoc. Like with the iodine experiment and with the in the vitamin C experiment and the temperature in the Rauscher experiment, it caused bizarre results. Imagine what would happen if, like, rocket scientists or doctors just overloaded on drugs or something. Secondly, one needs to test the answers before using them, because the obvious answers were just adding a whole bunch of iodine, heating it up to as close to boiling as possible, but that would have been foolish in other circumstances. This investigation was fun and it was informative. Does anyone have any questions?
Can you just kind of summarize your graphs just so that we can see what they show?
These are basically the averages that I stated in the results section. This shows the vitamin C clock reactions against the water temperatures. This shows the hydrogen peroxide amounts against the temperatures. As you can see, it does show a downward trend. But note that actually this is far greater than this amount. That's just where we stopped. Mm-hmm. The iodine one, again, same note. And it may or may not have been actually 0, but it was close enough. This is the Briggs-Rauscher one. This is the temperature one, and it goes up and curves down, which doesn't make any sense, but oh well. This is the Briggs-Rauscher reaction, one with the varying hydrogen peroxide. It went up, but after the 0 milliliters one, there's not much of a change. Any other questions?
I have a question. If you had the time and resources to really investigate this a lot further, let's say, like you would do in college to graduate, what would you do what might you do in terms of either applications or treatment, say, for your vitamin C clock reaction to really get a closer definition and to get statistical significance?
Okay, for the vitamin C one, there's a multitude of things. First of all, equipment wasn't the best. Even just getting laboratory equipment would help. You could definitely use better quality vitamin C stuff. Basically, I use ground up pills and from untested companies. So if you just got pure ascorbic acid, it would work much better. For the temperature, laboratory device would help if we could keep it up instead of just heating it up at the beginning. It would reflect much better what it ought to be reflecting. And many more replications are necessary. Time prevented it, but if you had a lot more replications, it would be nice. And also, just one more interesting thing that could be done, instead of just taking the varying water temperature, varying hydrogen peroxide, or varying amounts of iodine, and just doing them separately, you could like set it up as a table and do ones with 15 milliliters of iodine and have it set up against 0, 10, 20, 30, or however much milliliters of hydrogen peroxide at different temperatures and such, just so you could see it as a balanced thing and not just black and white, one or the other.
Thank you.
Any other questions?
Thank you.